So I'm going to do, let's see, maybe number 2. Let's do number 2 here. What's the problem with number 2? Why can't I solve it the way I've always solved equations? X is in the exponent. Okay. So I can't solve things where the x is in the exponent. How am I going to bring that down? What am I going to do to that to bring it down? Okay, so I'm going to take the log of each side. So I'm going to say log of 6 to the x equals log 99. So pretty much I just put a log in front of each one of those. Okay, why is that good? Why do I like what I just did? Because now I can move the x, right? I can put the x where? There we go. I can move the x down here because of that property we learned last week. So now I have x times the log of 6 equals the log of 99. And then what can I do to get x by itself? Divide. Yep. So I'm going to divide by log 6. Divide here by log 6. This cancels, and this part, the log 99 divided by log 6, that I can put straight in my calculator. So log 99, make sure you close your parentheses after that, divided by log 6, I get like 2.56. And just to make sure our answer makes sense, what I could do to check, I mean, this back here says 6 to the power of x should equal 99. So if I go 6 to the power of 2.56, look at where I come out to be. Why is it not exactly 99? Yeah, because I rounded back here, okay? If I had done 6 to the power of this big decimal, it would have been a whole lot closer, okay? Good? Does that make sense? Do you need to see any other ones in that section, 1 through 4?
Can you do 4?
That's three or 4.
Okay, 3 or 4. I actually think 3 is a little harder. Well, I guess they're about the same, but we'll do 3. What do we need to get rid of before we can even start in number 3? Okay, so that minus 5, let's add 5 to each side. So now I have 11 to the power of x minus 8 equals 59. Now what do I want to do? Well, I can't get rid of the 8 because it's up in the exponent. But what do I do to each side that lets me bring that exponent down? Log. Yep, so I'm going to go log of 11 to the power of x minus 8 equals log 59. Okay. Then I'm going to move this whole x minus 8 down in front. So I'm going to do x minus 8 times log 11 equals log 59. Okay, where am I going to go from here?
Divide log 11.
Good. Divide by log 11. Okay, so I end up with x minus 8 equals whatever this decimal is, log 59 divided by log 11. I end up with like 1.70. Now the only difference is back here, when I did that step, when I did the logs in my calculator, that was my final answer. Here I have one more step to take, right? What's my last step?
Add 8.
Add 8, yep. Add 8, and you end up with x equals 9.70. Okay. Let's just talk through number 4 real quick. What's the first thing you would get rid of in number 4? I would get rid of the 5. So I would divide by 5 first. Then I would do your logs and move the 3x down in front. divide by log 6. So you're going to end up doing log 20 divided by log 6. And then you'll have 3x equals whatever that decimal is. And then divide by 3.
When you do, wouldn't it be log 6 and log 4? So
Oh, you're right.
divided- Okay.
Yeah, good call. Yeah, I would have divided by 5. So this would actually be a log 4 over here, not a log 20. Thank you for catching that. Good. Okay, makes sense? All right, section 2. Pick one from section 2 you want to see.
6.
Number 6? Okay. So with these ones, when it's just a log equal to a number, usually I try to rearrange them to exponential form first. But before you can do that, you want it to just be a log by itself. So if there's any other numbers there, you got to get rid of them. So how can I get rid of that negative 2? How is this negative 2 attached to the log? Okay, this is multiplied, right? So how do I get rid of that? Divide, yep. So I'm going to divide by negative 2, divide by negative 2, and now I'm going to have log base 3 of 5x equals positive 2. Now let's take that and rewrite it as an exponent. Okay, like, you know how we do like the circle method, like the 3 to the power of 2 equals 5x. Does that sound familiar? Okay, so I would rewrite this as 3 squared equals 5x. Is that coming back to you okay? They're writing it as an exponent instead of a log. And then 3 squared is 9, so now I have 9 equals 5x. And then what would I do? Divide by 5, yep. I think it's going to be 1.8. Just double check that. Pretty sure. Yeah, 1.8. Yeah, so with this whole section, I would get rid of any other junk, okay, and then rewrite it as an exponent, and then you can usually solve right from there. So is there another one in here that looks hard that we can at least talk through? Which one, Emily? 8? Okay. So with 8, what's the first thing I would get rid of?
6.
I would divide by the negative 6, and then I would write it as 3 to the power of, let's see, that would be a positive 4 after you divide by the negative 6. So 3 to the power of 4 equals x minus 3. And then 3 to the power of 4 is 81, so then you would have 81 equals x minus 3, and then add the 3 over. Does that make sense? That process? Hopefully. I'll write that one out. I just talked through the whole thing, so I may as well. Divide by negative 6, divide by negative 6. So now I have log base 3 of x minus 3 equals positive 4. I'm going to rewrite it as an exponent. So 3 to the power of 4 equals x minus 3. Well, 3 to the power of 4 is 81. And then from there, if I'm solving for x, I would just add 3 to each side. So x would equal 84. Now I'm going to go off my screen here. Make sense? Good on that one? Okay. So these ones kind of fall into that category of like a log equal to a number. And then when it's log equals a number, you just rewrite it as an exponent. Usually you can solve from there. Okay. All right, let's look at part 3, where you have 2 logs. Okay, and this is the part that I don't feel like I did a good job explaining in the video. If I have log base 8 of x equals log base 8 of 6, I'm going to do a bad job explaining it again. If I have log base 8 of blah, blah, blah equals log base 8 of blah, 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 doesn't it make sense that the two blah, blah, blahs have to equal each other? Like if you're taking log base 8 on both sides and the logs are equivalent, then don't the things you're taking the log of have to be equivalent? Okay? So when I have something like this where these logs are exactly the same on each side, I know that this has to equal this. I know that those two things have to be equal to each other. So this is like the easiest problem on the whole page, right? What does x equal?
6.
Yeah, x equals 6.
Oh, wow.
Okay? So with all of these, really you're just taking this and making them equal to each other, like dropping the log. Okay? And you would have 4x equals x minus 3. Okay? 2x minus 5 equals 1. 4x squared equals 100. Okay, and then you can solve from there. So these ones, when you have like two of the exact same logs equal to each other, just ditch the logs. Easy enough on that section? Do we need to do more of that? One more? Which one you want to do? 10? Okay. So you got what I was saying, right, when I said that I could just drop these logs, and so I would have 4x equals x minus 3, right? Okay. So now how would I solve that? Yep, subtract an x. Well, I'm going to go over here. So 4x minus x is 3x. That's gone. So now I have 3x equals negative 3. Divide by 3. Divide by 3. If the two logs are exactly the same, and that's the only thing you have. If you look down at like, well, this next section, see how there's like 3 logs in a problem? You can't just drop all of those. We're going to talk about what to do with those in a second. But if it's really straightforward, like log of this equals log of that, and the bases are the same and everything, then you just drop the logs and solve the equation. Okay? So let's talk about then this next section, 13 through 16. The dropping the logs trick doesn't work unless it's one log equal to another log. Okay? Because when you have more than one log, like this here, remember that the rules for logs are a little different. However, I can combine these two into one log, and then I would have just one log equal to another log. Anyone remember when I add 2 logs together, what am I really doing with these two things? Multiplying, right? So I could take this left side and rewrite it as log of 7x. I just multiplied the x and the 7 equals log 37. Okay. Now what can I do with it? Now that I have that, can't I drop those two? Okay, once I'm at the point where I'm at a log and a log, then I can drop the logs. So now I just have 7x equals 37. Divide by 7, divide by 7. X equals, I have no idea. 5.2.
I mean, 2 nice.
Okay.
So you just,
Did I lose you, Carly? Are you okay?
yeah, I got it.
Okay. Pick one more from that section to do.
Number 16.
16, I figured. Okay, so the hardest part about 16 is figuring out how to combine all this junk. But we did that last week. Remember I told you that this was the lesson where kind of everything was going to come back together? Okay. So first of all, any numbers that are out in front, I would put those back where? Like this 2 right here, where does it really go?
Power.
Yeah, so this x is really an x squared. Okay. So I would rewrite this side as log base 4. How would I combine the 12 and the x squared? Yeah, it would be 12x squared. Right, with multiplication, because that's addition. And then minus log 2. So what am I going to do with the 2? If it's minus. Divide. Yep. So if I took that out and just gave you this, this is like your assignment from, gosh, last week, Thursday or Friday, where I was giving you a bunch of logs and saying combine them. That's all you're doing, is doing that combination. Okay, I added these 2, so that means I have to multiply those. And I subtracted that, so that means I have to divide by 2. Okay? Everyone okay on that combination part? Okay, stop me if you're not. And then that's going to equal log base 4 of 54. But now look at what we have. We have log base 4 of blah, blah, blah equals log base 4 of blah, blah, blah. So that means the blah, blah, blahs have to equal each other. This has to equal this. Okay? So my equation now says 12x squared. Actually, what can I do here? Can I do 12 divided by 2 and just make that 6x squared? So 6x squared equals 54. Okay, all I did there was 12 divided by 2 and made it a 6. Just made it look a little nicer. Now how do I solve this thing? Divide by 6. So now I have x squared equals 9. Square root it. And then, of course, when you square root, you get how many answers?
2.
Yep, so this should be plus or minus 3 as your answer. Okay. Does that make sense? Okay. And number 5, or part 5, is really just kind of the same thing we did up here, like where we combine the logs. So we're going to combine the logs, but then instead of having log equals log and dropping the logs off, it's going to go back to being one more like this one, where you write it as an exponent when you're done. Okay, because it's just equal to a number on the other side. Which one of those do you feel like doing? 18? Okay, so what's the first, if I'm combining the stuff on the left side, what's the first thing I should do?
Put the 2 in the power.
Yep, so make this a power 2. And then I would write this as log base 8 of, how am I going to combine these two?
8.
Yep, so that'd be 8x squared equals 2. But now I want to make sure you see how that's different from what we had up above. Up here, after I did that step, I had log equal log, and then I just scratched the logs. Okay. Here I have log equals number. So if I have log equals number, what's my next step from here? No. Okay, I'm going to write it as an exponent, right? So I'm going to write it as 8 to the power of 2 equals 8x squared. 8 to the power of 2 equals 8x squared. Well, what is 8 to the power of 2? 64, right? So 64 equals 8x squared. Okay. Let's divide by 8. Divide by 8. So now I get, again, I'm going to move over here. 8, because 64 divided by 8 is 8, equals x squared. And then let's take a square root. Now I'm going to get a decimal. That's okay. $2.83. Oh, and I guess that should be plus or minus 2.83 because we took a square root. Okay, how's that sitting with you?
Better.
Better, a little bit. I just did like half the assignment. Okay, so the other half is yours to finish up on your own. Hopefully, now that we've done those examples, you can go back to the ones we didn't do and get those done. Okay.